Advanced Functions. Grade 12. Unit 5.5. Rational Inequalities. In this video, you will learn how to solve rational inequalities in the simplest and most memorable way, not described in your books. We will treat all variables as real numbers. Complex numbers are not covered in this video. Inequality investigation. Let's start with a simple inequality that is always true: 1 is less than 2. What happens if you multiply both sides of the inequality by a certain number? We know that if we do it with equality, it will remain true. Will our inequality remain true? It depends on the value of x. Try multiplying both sides by 1, then by 0 and -1. The first operation gives the numbers 1 and 2, the inequality is still true, 1 is less than 2. The second operation turns both sides into 0, and the inequality turns into the equality 0 equals 0. Therefore, you should avoid multiplying both sides of the inequality by 0 when solving it. The third operation gives you two negative numbers, -1 and -2, and since -1 is greater than -2, the inequality sign is reversed, less changes to greater, and vice versa. So, the rule that you should remember and apply is that when you multiply both sides of an inequality by a negative number, the sign of the inequality is reversed. If you multiply an even number of times, the sign will remain the same. If an odd number of times, it will change. This rule also applies to division operations. Now, it's time to implement this rule in our next topic, solving rational inequalities. Solve the rational inequality. Division by 0 is undefined, so -1 and 3 must be excluded from the solution. Subtract what you have on the right side from both sides to create an inequality with 0 on the right side, and then simplify the left side using a common denominator. Now it's time to use the rule you learned in the previous topic and get rid of the denominator on the left side. You need to multiply both sides by whatever you have in the denominator and get just the numerator on the left side and 0 on the right side. However, you should be careful about the inequality sign. It will be reversed if the value you are multiplying by is negative. You should consider two cases separately, when the value is negative and when it is positive. X plus 1 is positive when x is greater than -1, and negative when x is less than 1. Likewise, x minus 3 is positive when x is greater than 3 and negative when x is less than 3. Thus, when x is less than -1, both x plus 1 and x minus 3 are negative, and the inequality sign will change an even number of times and remain the same after multiplication. When x is greater than 3, both are positive, the inequality sign will not change at all. Finally, when x is between -1 and 3, they have different signs, one is negative, and the other is positive, and the inequality sign will change once. Write it all down as two systems of inequalities. The first system gives you x is greater than or equal to 7, the second system gives you x is between -1 and 3. Now combine them and this is the solution. Here you used an algebraic strategy, very similar to the strategy you use to solve rational equations.